So another way that a lot of students like to know this formula is this, to do it in terms of moles. So moles of solute, I like to think of it as just molarity. So I use a capital M for molarity. I always use little feet on the M for molarity, so you know it's capital, times, and I'm going to put, instead of volume, V, I'm going to put L for liters. So moles of solute equals the molarity times the liters. If you're given milliliters, you need to convert it to liters before you work with this equation. That's how I like this formula to go. And when you have it this way, sometimes people have a hard time solving for the denominator liters, the way it's set up there in red. But the way I've got it there in black, it's also an easier way to solve for that liters there, because then you know just to divide by moles over molarity is how you're going to get your liters. All right, so another thing to be familiar with is brackets. So we use brackets to represent concentration. So if you ever see a question and it just says, what is brackets NaCl? It's saying, what is the molarity? What is the concentration of NaCl in molarity? So watch out for brackets. Sometimes it's like when test time comes around, it's like the smartest person in the class raises their hand and they're like, what do these brackets mean? And I don't tell them because we went through it in class. But sometimes people know how to do everything, but they don't know about those brackets. So make sure you recognize that, because you don't see it on every single question or anything. You may or may not have noticed when you got your unknown in the lab on Friday of last week there, it actually had it in brackets. I just said brackets, copper 2 chloride equals question mark. And by that I was saying the concentration of this unknown is question mark. Down below that, you may have something like brackets H+. So you could do it with the ions as well. So that's hydrogen ion is 1 molar. You'll see on your homework today, it's going to call that a proton. So H+, well, it was a hydrogen atom, a proton, and an electron. Once it lost its electron, it's just a proton. So sometimes we call H+ protons. And that's important for understanding acids and bases. And we call it molar, capital M, but it means moles per liter. So I know for that NaCl solution, the first bullet point, if I had a whole liter, I would have 4 moles of NaCl dissolved in a whole liter. Maybe I don't have an entire liter. Maybe I just have a little test tube. But the ratio is 4 moles for every 1 liter of that particular solution. All right, these may be on your sheet. Let's see. Yeah. So let's just practice using the equation here. It says calculate the molarity of a solution that contains 0.350 moles of Na2SO4 in exactly 750 milliliters of solution. So when you're going to solve with molarity, the first thing you want to do, anytime you have milliliters, you need it to be in liters instead. So I'm going to just move the decimal point 3 places to the left or divide by 1,000. So I know my volume is actually 0.750, actually with sig figs, just 0.75 liters. That's what I'm going to use for my calculation. If I'm solving for molarity, I set it up this way. Molarity equals moles over liters. So in this case, it's easy. You just divide your moles, 0.350 on top, over 0.75. Moles for every liter. I'll do that division real quick. You can do it with me. Calculator, just so you can do these if you don't have one. 0.35 over 0.75. Right, looks like we're getting about sig figs. We'll go with 2 sig figs because of that 750 milliliters. So I'm going to go with 0.47. And we just use a capital M. It means moles per liter. So if somebody else said 0.47 moles/liters, that would be okay. And then this is Na2SO4, so I'll label it as Na2SO4. All right, it's that easy. Moles divided by liters of solution. And notice the volume that you use is liters of the entire solution, not just the liters of water. It's the liters of the solution as a whole. Next one we can do, we're going to find how many moles of HClO4, well, that's our perchloric acid, strong acid, are present in 50 milliliters of a 1.5 molar solution of perchloric acid. All right, as soon as I see milliliters, what am I going to do? Convert it to liters, you got it. Divide by 1,000 or just move the decimal 3 places to the left. So that's 0.0500 now it's liters. All right, and we've got a molarity. So this time we're looking for moles, which is a very useful thing to do with that molarity equation. So I just always have in my head that it's moles equals molarity times liters. Mm, 1.50 molar, which means moles per liter, times 0.050 liters. All right, and this one I think I need 3 sig figs because of the 50.0 milliliters and the 1.50 molarity. So I'll call it 0.0750. And my unit here is going to be moles. And I'll be specific. It's moles of HClO4. Next week, we'll get into doing some stoichiometry again, but in that stoichiometry, we'll use the molarity equation as well. So, when we do stoichiometry, we want to be really specific about our substance. Yes?
So do you want us to keep sig fig based on your question or based on what we got down in our calculations?
Based on the question. Go back to the original question, because in your calculations, you might leave one out or type in something different. I know when I'm looking at this one, so I go back to even before I moved that, I see 3 sig figs here and I see 3 sig figs there. So I know my answer needs to have 3 sig figs. When I do that conversion to liters, I might be lazy and just call it 0.05, which is fine for your calculations and everything. But for sig figs, by the end, go back and remember that had a 3rd sig fig. Good question. And then the last one here, this one we're looking for volume. So this is where people most frequently make a mistake, especially if they go with the original definition of molarity, which we used in question A. In question B, where I've got that kind of rearranged formula, it makes it a lot easier to solve for volume here. So we're going to look for how many milliliters. We're going to be looking for our volume of 3.0 molar. There's a typo there, guys. That should say molar. Capital M right there. 3.0 molar NaOH solution are needed to provide 0.535 moles of NaOH. So for a question like this, I like to start it off with this version of the equation, moles equals molarity times liters. Then I can see I need to get to milliliters, but I'll solve for liters in this equation. If I divide by molarity, on that side it'll cancel. So moles divided by molarity is how I can get liters. I'm trying to write with my finger on here because my stylus is dead. All right, moles over molarity. So I want to get 0.535 moles out of this. And the molarity is 3.0 moles per liter, or 3.0 molar. So it turns out moles over molarity will give me my liters, and then I'll convert it to milliliters on the board underneath because I'm out of room. Looks like I need 0.178. I'll round my final answer, but 0.178 liters of the solution is what I need. And then down here, you could just move the decimal 3 places if you want to do that. You can multiply times 1,000, but we need to get this back into milliliters. So the volume underneath that times 1,000, or move that decimal 3 places. And also I'll go with just 2 sig figs. So 178 milliliters becomes 180 milliliters for my answer, just because they asked for it to be in milliliters. If they just say what volume do you need, you might as well just leave it in liters. But they asked for milliliters, and as you realize doing the lab, a lot of times it's more useful to measure these smaller amounts in milliliters. All right, so we've got an example of each there, solving for moles, molarity, and for liters. Other times, instead, they might give you grams. Did we ever use grams in the molarity equation? No. If they give you grams, you got to convert it to moles first. Or there might be a question kind of like letter B, but instead of how many moles of HClO4, they might say how many grams of HClO4 are present. So then your last step would be convert from moles to grams, just using the molar mass like we did in the last chapter. So never use grams in the equation itself. Always convert it into moles before you get started with it. All right, let's talk about mixing a solution. I usually teach this lesson before we do the lab, so you've already done this. You've seen all this stuff. Just to remind us, think about what we did, or if you are out that day, just to go over what we did. You'll take your compound. So we took our solid compound, and we figured out how many grams of it we needed. So we figured out how many moles we needed first and converted it to grams. You took the mass of it, and then we used that thing called the volumetric flask. That volumetric flask had that one line on there that was really important. The solute was added first, and then the solvent was added to fill it to the neck of the flask. And the reason I go over this is because, especially people who haven't made one before, like you already have, they say, okay, I want to make 100 milliliters of solution, so they might go ahead and get their solid solute, and then they get 100 milliliters of distilled water in their graduated cylinder, and they think they can just pour it on top of there. I don't know if anybody did that or not during the lab, but if you've done that, if you took 100 milliliters and you poured it on top of the solute, you're going to go over the 100 milliliter mark on your volumetric flask. And that's because when you gets into molarity, you're focusing on the volume of the entire solution. So the solute already takes up some of the volume, so you don't need the full 100 milliliters of water to make 100 milliliters of solution. The volume includes both the solute and the solvent as well. Last thing I want to talk about in this lesson and practice with is something called dilution, how to make dilute solutions. Something else you've already done. But when you did it in the lab, I made you do it with proportional reasoning because I want you to really think about it so you understood what was going on. Here's your shortcut. Here's your trick. If you didn't like that proportional reasoning method, I could have given you this formula from the get-go and you could have used it, but I didn't. I wanted you to think about what you were doing. So this formula, dilution equation, either you can put it in your notes, or if you were following along on this handout, this is what I was thinking about. You would put right here for dilution equation, what we see in the box here. I think there's 2 more variables, yeah. All right, so it's easy to remember. It's just MV equals MV. But then on the left side, we put 2 little C's. Those stand for the concentrated, or sometimes called the stock solution. And then on the right-hand side, we have the little D's, and that stands for the dilute solution. So the molarity times the volume of the concentrated solution equals the molarity times the volume of the dilute solution. when you did the lab, one of the test tubes that you prepared needed a 0.16 molar concentration. And you guys thought through it and figured out how many milliliters of the stock solution you needed and how much water you needed to add, because you needed to get a final volume of each of your test tubes, if you remember, was 10 milliliters. And what you had to figure out was how much stock solution do you add and how much water should you add to top it off with to get to the total of 10 milliliters. Well, if I had given you this formula first, you could have solved for it this way instead of thinking about it proportionally with the chart. We could have used this equation up here. I'll write this on the screen. So our equation could be the molarity times the volume. I always just write it this way first and then I add the little c's and the d's, equals the molarity times the volume. Remember, molarity times the volume is the number of moles. When you do a dilution, the number of moles isn't changing. All that's changing is the proportion that's the stock solution, and then you're just adding water to it. So concentrated on the left, dilute on the right. Sometimes you see it with 1s and 2s instead of c's and d's. All right, the molarity of the concentrated, that was our stock solution. It was 0.2 molar. All right, times the volume of the concentrated, that's what I don't know. I'll call that X, because I was trying to figure out how much stock solution do I need to put in that fourth test tube. And then the molarity of the dilute, that's the solution you're trying to make. We wanted to make it to be 0.16 molar. And I needed 10 milliliters of that solution. Now, I told you a minute ago that you have to use liters every time you work with the molarity formula. With dilution, you can use any unit you want for volume as long as it matches on the left and the right side. So you can use milliliters, you can use liters, you could even use gallons or cups if you needed to, because as long as it's the same on both sides, it'll all work out. So when you use the molarity equation by itself, always use liters. But when you use dilutions, just make sure your volume unit matches. All right, and then from this point, I can just kind of simplify this and solve for x. 0.20x equals 1.6, I think. And then I'll divide. Of course, I know what the answer is because we already made this. It's going to be 8 milliliters. So I needed 8 milliliters of the stock solution. And then I got it up to 10 milliliters because remember you added 2 milliliters of water on top of that. So that's one way. If the numbers weren't quite so friendly, you know, when we looked at the chart, you could figure it out. Okay, it's all related to this part of 10. But a lot of times the question, maybe the answer turns out to be like 8.333 milliliters or something like that. And so instead of thinking about it proportionally, we need a formula. We need something like that to work with. So that's called the dilution equation. It can be used to find out how much stock solution you need. It could be used to find out what is the molarity of the final dilute solution if you knew some other things to start with. So this is on your sheet also, I think, yeah. Let's look at this. It says you have a stock solution of 14.8 molar NH3. So that NH3, just as we start seeing some of the same things over in this class, that's ammonia. All right, so that's 14.8 molar ammonia is really strong. That's something that has to be kept in the fume hood for sure. How many milliliters of this solution should you dilute to make 1,000 milliliters of 0.250 molar NH3? All right, it's a dilution question, so we're going to use the dilution formula for this. I'm going to know that molarity times volume equals molarity times volume, which is another way of saying the number of moles doesn't change. It's just we're going to change how much water is in there. Concentrated on the left, dilute on the right. All right, and then also just to organize this, I should have done this first. So just on this side, let's list the things that we know and what they are. So the molarity of the concentrated, That's our stock solution. That's the 14.8. Just kind of listing my variables as I'm reading about them. I should have done this first. All right, now it says how many milliliters of this solution? Oh, so it's asking me to find out about the volume of the concentrated solution because it says how many milliliters of it. Should you dilute to make? All right, what's MD? What's the dilute molarity listed in this equation? I'm calling some people to help me here. Piper, what do you think the dilute molarity is in this question?
I believe that it's 1,000 milliliters.
That's going to be the volume, all right? So that's going to be the volume. What's the molarity of it going to be? You got it, 0.250 molar. And then you told me there the volume's going to be 1,000 milliliters. All right, now let's work through it. 14.8 times x equals 0.250 times 1,000. All right, so just simplify it, and I'll take my units out and save those for the answer. So 250 over 14.8. All right, looks like I need with sig figs. How many sig figs should I probably round my answer to in this one? If you could look back up what's given in the question. Shelby, look up at the question. Based on that, how many sig figs do you think I need for my answer here? I'm going to go with 3 because 14.8 has 3 sig figs. 1,000.0 actually has like 5 sig figs. And 0.250 has 3 sig figs. So that's why I'm going to go with 3 sig figs. 16.9. All right, so I need 16.9 milliliters of the stock solution. And it's called a stock solution because that was the idea. That's what you would keep in the stock room. That's what you would prepare and then keep so you could dilute it out later on. All right, let's do part B as well. I don't know why I don't have it on the PowerPoint here, but let's do part B. I'll clear the screen to do it on the screen. Does anybody need more time with part A? All right. Okay, so it says if you take 10 milliliters portion of the stock solution and dilute it to a total volume of 0.500 liters, what will the concentration of the final solution be? All right, this time I'm going to list everything first like I should have last time. So let's think about what we know. I'm going to just say MC, VC, MD, VD. All right, so we're going to take 10 milliliters of the original stock solution. So therefore, what's the molarity of the concentrated solution here? Carter, what should we use for MC here? Yeah, we're going to use that same 14.8 again. It's that same stock solution. What about VC? What's my volume of the concentrated solution this time? What do you think, Will? Yeah, broad fit. It starts off the same, and actually you got the question that's different, all right? So It said, let's look at part B again. It says, if you take a 10 milliliter portion of the stock solution, remember stock solution is concentrated solution, and dilute it to a total volume of 0.500 liters, what will be the concentration of the final solution? So what's our volume of the concentrated solution?
I thought we just did this.
Mhm.
I just really confused.
So does so we have part A and B on here, right? Are you looking on here? So,
I have the same paper.
okay. So
I thought that was all one problem.
it was on my screen, but your paper has that part B there, so,
I thought that was all one.
okay. So, Ainsley, what do you think we might use for that VC? I saw your hand up. I thought you wanted to answer. Yeah, good. It's 10 milliliters because the concentrated is the stock, and they're saying you're taking 10 milliliters of the stock solution. All right. Molarity of the dilute solution. Vivi, what should we put for the molarity of the dilute solution here? Good. Yeah, good. It's X. I'll call it X, or you can call it MD, because we're trying to find what will be the concentration. Concentration is molarity. And then, Maddie, what's the volume of the dilute solution?
0.500.
Good job. And you told me a unit here. Now, this is significant because the units are different. We need to pick one and stick with it. I don't care if you use liters or use milliliters, you'll get the same answer either way as long as you're consistent. So this is a personal choice. Jonathan, you get to pick, all right? There's not a right or wrong answer. Do you want to go with milliliters or do you want to go with liters for this one? Liters, all right. You like liters. All right. So that means that's probably easier to convert out of. That means we need to convert one of these guys. Let's convert our milliliters to liters before we get started so at least they match. So I'm going to go with 0.0100 liters. Now both of our volumes match. And actually, Jonathan, that's a safe bet. It's always safest to go with liters because, if you have to use the original molarity equation, that needs to be liters. So that's a good one to choose there, even though either answer would give us the right answer. All right, let's use our equation. Molarity of the concentrated times volume of concentrated equals molarity of the dilute times the volume of the dilute. So we'll go with 14.8 times 0.01. Again, we'll go back to our original equation to figure out our sig figs. Equals, this time I'm looking for this guy. Looks like I'm getting for my molarity of the dilute, it's going to be about 0.296. Then I'll figure out my sig figs. All right, so I'm seeing originally in the equation I had 3 sig figs there. I've got 3 sig figs there. I've got 3 there. So how many sig figs should I have in this answer? Probably Claire? 3 is a good answer, yeah. So I'll say 0.296. What's my unit going to be? Is my unit liters or milliliters or something else this time? Davis, what's my unit here? Molar, good. Molarity or molar. And I'll be specific. It's that molarity of NH3. So that's working with the dilution equation. Some things to keep in mind. The stock solution is your concentrated solution. All right. Well, what questions do you have about this equation so far or anything related to that? The good thing is you guys have made a molar solution, so you kind of have an idea of what this is all about. Some of the questions on the homework are going to be about grams instead of moles, so just know sometimes your first step is to convert grams to moles, or sometimes your last step is to convert moles to grams, if that's what the question's asking about. And I think that's it. if you don't have any questions, I want you to just use the rest of the time in class today to do a couple of things. Maybe I could even say 3 things. Number 1, work on the packet. Aqueous 01 is what it's called, so I want that to be finished by tomorrow. 2, you can get with your lab group if you need to and say, hey, we need to figure out who's going to do what in the lab report and make a plan for that. Talk about that stuff. Use the rubric as you make your plan. And then 3, study your strong acids and strong bases. So you got a busy day ahead. All right? Feel free to go to your lab stations if you need to talk to your lab group and you'd rather get together back there.